Hi, my name is Avril Sauter, and we're talking about CCNA Wireless. Now, in this lesson, we're going to look at some of the advanced design principles, some of the concepts that you should be aware of when you're planning out, implementing, and running your wireless LAN network. So let's first take a look at spectrum analysis. Now there's a major difference between scanning RF channels and doing a spectrum analysis. So let's talk about that difference. When you do scanning, you use a tool and it will find out what wireless LANs are there, it will give you the SSID, and it'll tell you what channel they're using, and it will tell you the security. So it will tell you, hey, I'm using WEP, no authentication, or maybe I'm using WPA2. So it will tell you the authentication and potentially the encryption in use. A spectrum analysis tool will actually look at the spectrum. And so you'll get charts like the ones you're seeing here. The top one here is showing a real-time FFT. That's a fast Fourier transformation plot. And what it's showing me on the x-axis at the bottom is the frequency. So this is the 2.4 gigahertz band, and on the y-axis you can see the power level that is being received at by my Spectrum Expert tool. And so what this is telling me is, look, there's a lot of noise in channel 11. So if I was wanting to deploy a single access point in this location, I would look at deploying it on channel 1 or channel 6. The diagram below is a sweep spectrogram, and a sweep spectrogram, literally each one of those horizontal lines where you see the vibrant color is telling me how much noise that is receiving, kind of like the signal strength. And again, it matches with the graph above, and you can see that there's a lot of noise and interference where you see all the red colors. And then you can see out on the outer skirts blue, which is telling me, hey, there's not much happening out there, there's not much transmission. And the spectrogram actually kind of gives me a feeling for how much interference there is over a period of time, because each one of those lines represent 1 minute. So it gives me a sense of, is this channel being 100% occupied, 10% occupied, etc. Now a tool like the Cisco Spectrum Expert will actually go about, and when it detects interference, it'll try and work out how that interference has been caused. And different technology creates different patterns, and if that technology is well known and is standards based, those patterns, those RF spectrum patterns, can be analyzed, and a tool like the Cisco Spectrum Expert can say, hey, there's a microwave oven operating here. There is a DEC cordless phone. And again, depending on whether the technology is standard based, a Cisco Spectrum Expert tool can not only say, hey, that's probably Bluetooth operating, it can actually go ahead and read the Bluetooth messaging, which means that it can not only tell me that there's interference in that band and that it looks like Bluetooth, it can actually give me details about that system. It can give me things like MAC addresses, system names, etc. And why is that important? Well, because it makes my life easier. So if I need to remove sources of interference, it helps me find the source of interference. Oh, look, I'm looking for this type of access point. I'm looking for this type of cordless phone, and it helps me find it, locate it, and then I can have a conversation with the customer. Can we remove this device? Now, if you're going to perform a layer 1 spectrum analysis, there's some steps that you need to go through. And step 1 is you need to prepare. So before you even get out onto the customer site, you want to get hold of any floor plans or blueprints. You want to look at them, see what you're seeing on there. Is there any areas that you want to spend more time on? Where are you going to get the best sources of data? What kind of tools do you want to take out given that environment? And here it says make sure your laptop battery is full. Well, I always take spare batteries with me because when you're walking around with a laptop doing the analysis, there's nothing worse than going, oh, my laptop's just died, I need to plug it into a wall jack. So I always make sure I have enough battery power to do a full working day. Step 2 then is once I've got all my preparation, I must have some floor plans, otherwise I won't be able to match the analysis with the floor plan. So then what I do is I will just walk around the facility, and then I will log the time that I've spent in certain areas, and I'll spend more time in some areas than others. And you need to walk at a fairly slow pace to capture the information. If you walk too fast, what's going to happen is your spectrum analysis tool is going to be making measurements, but it's going to be over an expanded distance. And so you want to stop there long enough that it's taking some good measurements in each of the locations. And then I keep the screens up and visible so I can see the real-time FFT plot, the sweep spectrogram that we just talked about. I also have other ones like duty cycle and interference that I'm just keeping an eye on, and if I see a major source of interference, I will stop until I've diagnosed the sources of that interference, and then I'll start walking again. Here it says scan each area twice if possible. The reason it says that is interference may be there 1 minute and then gone another time. I'll make sure that I scan cafeteria and kitchen areas during lunchtime. So that's all part of my step 1 preparation when I'm doing my planning as to where I'll be when I'm doing my scanning. Step 3, I always verify the information has been captured. So I store it in a file. So if I'm using the Cisco Spectrum Expert tool, it'll say to me, do I want to capture that data? And then later on I can replay that captured file as if I was actually walking around. So if I miss something, I can go back and actually look at it later on. So then I analyze the results. Now, if you're familiar with the tool and how to do this, you can do the analysis while you're walking around, or you can kind of say, okay, that's the problem, and you can start making notes. Some people prefer to look at it when they get back to the home office by replaying the captured file. Again, I just prefer to take more time when I'm on customer premise and do the analysis there, but that's a decision you'll have to make. What I want to do is I want to make sure that I've captured sources of information and I've written them down, and I'll write them down on my site plan. And I will also take screenshots of significant graphs while I'm walking around because I'm thinking about, oh gee, how do I capture this and present it to my customer? And of course you need to have a good understanding of how to understand these results. And the only way you can really do this is by using the tool and just getting experience with it. And here again we're looking at the reports and results that you can get from the Cisco Spectrum Expert tool. Now in this specific tool it'll have a duty cycle. And a duty cycle just tells me the RF utilization. So if I'm hearing a lot of noise interference, maybe there's the existing wireless LAN network, whatever it is, but I'll get an RF utilization. It will say this channel is 50% utilized, is 10% utilized. If I'm in an environment where it says 90% utilized, I'm like, whoa, what's the cause of that? And I need to understand it. If the customer is upgrading from a B access point to an 802.11n, 90% utilization may not worry me too much because I'm like, okay, well they're using B and it's very low data rates, and the utilization will go down once we're up at the much higher data rates. Interference power, this is the maximum power of all the signals within a channel. and again is telling me the total source. I don't know what that's made up of. If I want to take a look at what that's made up of, there are other screens that I would look at within the Cisco Spectrum Expert, so I can see perhaps the devices that are triggering that much interference to happen in the band. And bear in mind here, I'm looking at the axis here as well, and what I want to do is I want to make sure that is below a certain threshold, because anything above a threshold, what it's going to mean is that the more interference I'm going to have, the more access points I'm going to have to deploy to overcome that interference. If the interference is so high that I can't overcome it, then I need to start thinking about how do I shelter myself from those interference sources. I'll look at my signal to noise ratio, and again here this is particularly important if I'm looking at existing access points. What is that signal relative to the noise and interference that's happening in that band? Sweep spectrogram, you saw that on the previous slide, and it just gives me a visual representation for what's happening over time. So if I see a 50% utilization on the duty cycle, when I look at the sweep spectrum based on the profile, I can say, oh, look at that, I'm getting about a 50% duty cycle, and I'm by the cafeteria. Oh yes, that's the microwave ovens. I can see that. It's normally around channels 7, 8 and 9 where you'll start to see microwave ovens causing problems. So it helps me detect sources of interference. Now, in the previous lesson, I talked about basic design principles and how you can use tools to actually predict where you need to place your access points. But in this part of the lesson, I want to take a look at how these tools work and give you some insights so you can start thinking about and start using these tools. Now, when you're thinking about using these tools, there's some prep work you need to do. And the main thing here is to get the floor plans. And there's different formats that tools will take. The wireless control system and the Air Magnet Survey Pro will incorporate different images, so you can have CAD files, PNG files, JPEG files. So always check when you get your floor plans that you have them in a format that you can bring in to the tool itself. And so you bring in those floor plans, and that's your starting point for these tools. The first thing you need to do is you need to know the measurements of the floor plan, and you'll put those into the tool. And if you get it wrong, you're going to get some crazy results. You will also want to make sure on those floor plans that all the walls and the doors are identified and that you know the construction of those walls. There's a big difference if you're planning out a network and the glass is clear versus that reflective glass that has the metal in it. Then you want to select your tool. As I said, there's a lot of tools out there. I'm going to talk about the Cisco Wireless Control System Planner function and the Air Magnet Site Survey tool. Now, if you're going to use the wireless control system, step 1 is you would go into the Monitor tab and select Maps, because you are going to import your floor plans. If you're dealing with an outside environment, then you can select Google Earth Maps and actually get Google Earth to scan down and give you a picture, an image of your outside area. Once you've done that, then you'll select the planning mode. And when you do that, what will happen is it'll display your map on the screen and you'll be able to start your modeling process. So once you've got your map loaded, then what you're going to do is you're going to fill in the obstacles. And to do that, you click on the button that I'm showing here called Map Editor. And then you'll be given this ribbon that's displayed in this diagram here. And you can then use that to add walls and doors, etc. And so you can start to draw out your site plan, putting in obstacles, etc. Step 3 then, once you've got your plan and you've put your obstacles in, is then to place your access points. And so you click on the Add AP button and it will bring up this menu option that you see here over on the right. And you can select the model of the access point that you want to deploy and the antennas that you've got on it, the protocols, and then whether you're deploying for data, voice, or location. And be very careful here. Make sure you select the antenna and the access point that you're actually deploying. Make sure that you do select voice or location if that's what you're going to be using it for, because voice and location will populate the map with more access points because you need more overlapping coverage with a voice and a location network than if you're just doing data. So that was how you use the wireless control system by Cisco. Let's now do exactly the same thing using the Air Magnet tool Survey or Survey Pro. Now, step 1 on this tool is to launch the Air Magnet Survey Pro tool and create a project. So you give it a meaningful project name and you decide where on your computer you want to store that information, which directory you want to use. You do the same thing as we did with the wireless control system. You import your floor plan. There are more options in terms of formats in the Air Magnet Survey Pro tool than there are with the Cisco wireless control system, but it has all the basics that you'd expect. Once you've imported your floor plan, you then select Next. So once you've loaded your map, the new Project Wizard screen will appear. And you'll enter in the environment, and you can choose here a closed office, open space, commercial, etc. And it's important that you define it correctly. However, later on you can actually optimize it a little bit better. So basically when you choose this environment, it changes the planning algorithm slightly. And so it's important to get it right, but you can fine tune it a little bit later on as well. So now you've defined the environment. This is also where you'd also decide the size of the map that you've put in. Again, just like we talked about with the wireless control system, very important that you put those measurements in. And you basically then say next and say finish. And then you get into the point where you can start adding your obstacles. So there is a navigation bar at the bottom of the screen that you can see, and what you need to do is you need to click on the icon that's called Planner that's at that bottom, and that will then take you into the planning mode. Once you go into Planner, you'll see the icons that are shown over here to the right. One of the things that's also there is Create Wall, and you can also see things like rectangular areas, arbitrary areas, elliptical areas, rectangular areas, etc. Now, the first thing you want to do is to create a wall and draw the walls around your site. So you create the wall, create the perimeter of your location. You specify the material of that wall because, again, the closer you are to the right material, the better the accuracy, and you'll find that this tool has more options and hence will give you a better accuracy, in my opinion, than the wireless control system from Cisco. And then you start drawing in the other obstacles using the other icons that you see here. And you put in windows and cubes and doors, etc. And remember to save often. There's nothing worse than keying in all of this information only to find out that your computer crashes or something and you lose it. So remember to save often. Now in Air Magnet, again, you need to go in and specify what access points you're using, and if it doesn't recognize the access point, you can key in the attributes of that access point so it can improve the predictivity. But once you've got all the information about your walls, etc., and you've defined what access points you're going to use, you then click on the advisor function, and then the planner will automatically suggest locations for your access point and show you a heat map. And you can move those access points slightly in order to optimize it, etc. And now you have a prediction of where you should be placing your access points, just like you did with the wireless control system. And again, remember, this does not replace the need to do a site survey. It's a supporting tool that you can use, and one of the great benefits of this tool, not only does it confirm your understanding, but you can then use this to show your customer exactly what you will be deploying. Next on our list of subjects when it comes to advanced design considerations is a discussion on voice over wireless LAN. And this is actually really important that you understand some of the implications and how, if your customer says, yes, I want to do voice, you need to plan out the network differently than if it's just saying data only. So let's talk about that. First thing is, let's take a look at the portfolio of IP phones from Cisco. And again, on the wireless network, there may be other voice communication devices. Here I'm just showing you the Cisco IP phones, and you'll see that there are 4 models, and they are all ABG. So at this point, there is no N IP phone from Cisco. Now, in terms of features, the 7121 has a wired headset. What do I mean by that? Well, it means you have a Wi-Fi phone, so you can take it out of the docking stations and walk around. But while you're talking, you either hold the headset up to your ear, or else you use a wired earpiece from the phone to your ear. Whereas the 7125, that one introduced a Bluetooth headset, so you don't have to hold the phone up to your ear to have a conversation. You can have it in your back pocket and then have a Bluetooth earpiece. It's also ruggedized, so for people in environments that may drop it. The 7125 is for a hazardous environment, so it's got a cover on it should things spill on it. So if you're working in a manufacturing environment, for instance, that can be quite useful. And then the last one is the 7926G, and this one has the capability of doing 2-dimensional barcode scanning, as well as being in a ruggedized format. If you're not familiar with the IP codes, this is ingress protection rating. So it basically says how this device is rated when it comes to things penetrating into that device. Like, can you get splashed water on it and will it be okay? Can you submerge it into water for so many seconds and it be okay? So these ratings are done outside of Cisco, their industry ratings that rate your phone and how well it's protected against penetration from substances outside, like liquids. Now, one of the things you want to do is to determine the cell boundary. And when you think about this, your access point maybe could go all the way up to transmitting at 1 watt. But if you have an IP phone, for instance a Cisco 7921G, that has a maximum power of 40 milliwatts. So even though the phone would be able to hear the access point can't hear the phone. And so you have to determine your cell boundary based on the weakest or the lowest power device that you have on the network. And so if you're doing IP phones, chances are those IP phones are the lowest power device you have on your network. And say for instance this IP phone has a maximum power of 40 milliwatts, you might actually want to reduce the transmit power of your access point down to about 25 milliwatts. And so when you do your cell planning, you want to deploy and configure that access point assuming 25 milliwatts, which means that you're going to have a lot more access points because you're not assuming the maximum transmit power. So bear in mind you must balance your deployment, catering for the phone signals being able to reach the access point. You don't just look at the access point outward signals. You have to consider the transmissions in the other direction. Now here's some boundary recommendations for voice. Now ideally for voice, what you want to do is you want to disable any data rates below 24 megabits per second on your access points. What that means is it will shrink your coverage because you won't be able to go as far as you would be if you were able to transmit as low as 1 megabit per second. Now if you have legacy 802.11b devices that you need to continue to operate, then Cisco recommend that you set the lower data rate at 11 megabits per second. But if you don't have B, then up at 24 megabits per second. And by doing this, you're preventing your VoIP devices connecting out at low data rates where they may not get the best performance. So you're shrinking up the cell, reducing the coverage so you don't get the lower data rates on the edge of the cell, and ensuring your voice is able to transmit at a higher data rate. Now if you're deploying the 7920 or the 7921G Cisco VoIP phones, then Cisco has several recommendations as to how to plan out the network. And again, if you're deploying a different manufacturer's IP phones, these numbers may be different. These are specific to the Cisco products. So the first thing they recommend is that you do a 20% cell overlap. So when you're looking at the overlap of area between adjoining access points, it should be at least 20% in the 2.4 gigahertz band. In the 5 gigahertz band, they actually say it can be a little bit lower, maybe 15 to 20%, and that's because there's less interference in the 5 gigahertz band. So they're recommending more cell overlap in the 2.4 because there's more interference. The other thing they're recommending is that when you do your cell planning and your site survey, that the edge of your cell boundary is defined by minus 67 dBm, i.e. if your signal drops below that, you would be considered outside of coverage for a VoIP phone. And so what this means is that your cell size and the area you're covering from the access point when you do VoIP is a lot smaller than if you're doing data. And so that defines your cell boundary. And so when you're thinking, oh, where do I need to deploy my next access point, using a 20% overlap and a cell boundary of minus 67 dBm is how you should be planning out your network. Now, they also recommend that if you have two channels like I do in this diagram, I have channel 1. So they also recommend that if you have two access points that are operating on the same channel, like I have in this diagram, I have two access points both on channel 1, that there is a distance between them. And you define that distance by the signal strength of the signal coming from one access point should be no greater than minus 86 dBm when it gets the cell boundary of the second access point. So you need to keep access points that are operating on the same channel separated by at least minus 86 dBm. And again, that's from the the access point to the edge of the cell boundary of the second access point. Now, earlier in this lesson, we talked about using the wireless control system to do planning of my Wi-Fi network. And one of the things that you might want to do is take a look when you're doing this planning under services, select data and see how many access points you get, and then select voice and see how many access points it suggests, and you will see that it deploys significantly more access points if you select voice, and this is because it's assuming that the signal strength on the cell boundary is a lot greater than what it would be if you were just doing data. And the reason is this gives you really good performance when you're roaming around making that voice call and transitioning between access points. If you don't deploy those access points, then chances are you will have problems with drop calls or quality of service on those calls when you're roaming around in the environment. So remember to select the voice tab if you have VoIP phones operating in your wireless LAN. Now, one of the tools that's available in the wireless control system, and this is why you really want to make sure you do import the maps into the wireless control system, because this will really be valuable for you, and you put in the walls, etc., and you put in precise locations of where you've deployed the access points, because once you've actually deployed your access points, you can actually go out and run calibration measurements that can be fed back in to the network, into the system, and it can actually predict where you have good coverage and where you may have problems having coverage with making voice calls. And so here over on the picture here on the right, you can see I've got my access points placed, and you can see most of the area is ready to support voice calls. I've got a few areas where it's yellow, where it's saying, hey, this marginal may not be so good, but it's probably good enough for deployment. And then you can see the red area where it's saying, hey, this isn't voice ready. And if I get complaints from users that are talking about drop voice calls or a lot of noise or dropped packets so that they're hearing silence on those voice devices, and I can marry that up with what I'm seeing on my wireless control system, it really helps see where the problem is. I can then use my planning tool to say, oh, well, what happens if I move the access point here and here? Oh, and what if I put another access point here? Will that address the problem? And I can do that from the planning tool. And then, of course, I will go back out and take some measurements to confirm my findings. So the next thing we want to talk about in this lesson is sample report templates. Reporting on what's happening in the wireless environment is so important, not only if you're doing a deployment and your customer wants to know what's happening and why, it's also very important if you're supporting a wireless LAN and you want to get justification for perhaps buying more equipment or explaining the problems that users are reporting. So understanding how you can generate reports, what kind of reports, is actually very, very important part of understanding wireless networks. So when you're planning out a wireless network, what kind of data should you include in your report? Some of the critical things that you want to make sure are included include any diagrams, any floor plans. That's absolutely important to sort of show them where the coverage is, where you're deploying access points. Always include a suggestion about your observations on problem areas so that you have it documented, the customer has an opportunity to understand, and you can have a conversation about it. Always show the results of your spectrum analysis. It just makes you look highly professional, makes it look like you really understand RF, and it really builds trust in people when they see the results of that. They may not understand the analysis, but it really builds a comfort feeling that you really did your analysis and that this deployment is going to work. Always put in information about the supporting infrastructure, and particularly if any changes are needed to that infrastructure. That's important because the person's going to pick up this report and going to be deploying it, and you're going to save them a lot of time if you're going to include information about what infrastructure is there, what the IP addressing scheme is, what the VLAN mappings look like. So make sure you include as much information about the infrastructure as well as the wireless piece in these reports. The information about wireless equipment, what's been installed, what you plan to install, the access points, the antennas, the controllers, the mobility service engines, switches, etc. Everything you plan to install should be listed here, and almost consider it like an equipment inventory list. If you've been able to use a predictive model, and I would recommend you do that, include the heat maps and the coverage maps and explain to the customer this is what you're expecting to see, what kind of data rates, what kind of performance. Have that conversation with your customer, with the IT department. And then I always like to include a list of recommendations that would improve performance. And again, sensitive issue if you're going to say to them, please can you turn off these interfering sources, but you can certainly make recommendations. Like for instance, you may say, I'm recommending deployment in the 5 GHz band because we have these cordless phones in the 2.4. If over a period of time they can be moved away and moved to a VoIP phone, then potentially you can re-look at the 2.4 GHz band. You can make recommendations like that. Now, when you look at these reports, always put a nice cover over them, put a table of contents in there so the customer knows where to find things. Always do a brief summary at the beginning for management that don't have time to read the whole report and just want to get the highlights. Things like, this is the coverage, this is the expected performance, this is how much it's going to cost. These are the services I expect to run. This is how I did the project. So summarize the project for executives. And then put all the detail behind that. As much detail with descriptions. The more detail, the better, because this is going to be useful for you. So whatever information you collected, put it in this report. And again, always use appendices. So if you don't have to write detailed paragraphs, a lot of it can be, here's a list of what I found. Here's a list of the equipment I plan to deploy. So you can put it in appendices. It saves you writing paragraphs, but it captures all of the information that you have in one report. I always like to get a signature on my report, and I like to get a signature to make sure that it was received, and I like to make sure that signature is by somebody who's in a decision-making role. So that way, if there's any surprises later on, we can go back to that report, back to the person who received that report and say, we talked about this, we discussed this, here's where it is in the report, and here's the person with some authority that took ownership and received that report. So this is a personal preference, having been exposed to problems over the years. I find this a very valuable snippet that I'm giving you from personal experience. Tips for success. Take your report, sit down with the person that's going to approve the project and take them through the report. I always like to get someone else to do a quick spell check. For me, a quick technical edit pass. Very hard to do yourself, so always good to get a third party to do it. And I normally exchange that offer with a colleague. I'll do theirs, they do mine. Make down notes on the report for things that you want to highlight to your customer. Look, pay attention to this, notice this. So make sure that you're taking them through the key points. You don't want to take them through word by word, but you can just make sure they know what's in the report and where the key content is. Never use colored paper. Back when I was at university, I would use colored paper to submit my reports, and I would even put perfume on them to make them more fragrant. I'm not sure if it really helped me get a better grade, but it's the sort of thing you do when you're a student. Don't do that in the professional setting. Use white paper and quality white paper, especially if you're using color graphs, because otherwise it becomes more difficult to read. Put in a nice binder. You don't want papers which are falling all over the place when you're talking with your customer. And again, talk them through it. If they have concerns or they want changes, be willing to make those changes. Trust me, it will make the deployment and the relationship much better down the road. Thank you for listening.